graph the polynomial f of x equals x to the third plus 5x squared plus 8x plus 4. Use end behavior. So first we're going to look at end behavior. So if I'm looking at end behavior, I'm looking at my leading degree, and that's x to the third. So that should tell me that my arrows are going to face in opposite directions, and that since this is a positive coefficient, that means it's going to be positive at the right side, so that means the left side has to be down. Okay. So now that I've found my end behavior, I have to find my zeros. So if I'm looking for my zeros and they don't give me any of my potential zeros, I have to do the P over Q. So the factors of 4 and then the factors of my coefficient in front of my leading term, which is 1. So first my factors of 4 is plus or minus 1, plus or minus 4, plus or minus 2. And then my factors for 1 is just plus or minus 1. Okay, so you're going to randomly pick a number from the top and pick a factor for the bottom. So I'm just going to randomly pick negative 1 as my first potential factor. So I'm going to pull the coefficients from my polynomials. So that's 1, 5, 8, and 4. So 1, 5, 8, and 4. Bring down the 1. Negative 1 times 1 is negative 1. 5 minus 1 is 4. 4 times negative 1 is negative 4. 8 minus 4 is 4. 4 times negative 1 is minus 4. Since my remainder is 0, based on the remainder theorem, that means it is a factor. So now I'm going to write my reduced polynomial. So this is x squared. Because remember, my original polynomial is x to the third, so this one is 1 less, so that's x squared plus 4x plus 4. So now I can factor that because it is just x squared. So x squared is x times x. Since there's just a 1, I'm going to think what two numbers multiplied together gives me 4. But when I add them, also gives me 4. So that has to be 2 and 2. Please remember, since this is x squared, you could also use the quadratic formula, and that is absolutely okay. So now I'm going to write this factor from up here, which is x plus 1. So now that I have my zeros, I'm going to go ahead and graph them. So I have negative 1, negative 2. And so now I'm just going to connect the dots, which is kind of based on multiplicity. So this negative 2, since there's two factors with that, that means my multiplicity is a positive 2. So when I get to that, it's going to bounce off, so it's going to touch it and then go back down, and then it's going to be negative 1 right there, and then it goes back up, so it's like that.